Hello, Matthews, Gatos here. In this video, we're going to talk about the difference between parallel and perpendicular lines. Parallel lines are any set of lines that run in the same direction. They are also equal distance apart. So if they run in the same direction, are equal distance apart, they're never going to intersect. We denote parallel lines by using a symbol that looks like parallel lines themselves. That's the symbol for parallel. Let's look at an example here. So in this example, I have a quadrilateral. I want us to identify the sets of parallel lines. The slope has already been calculated for us, and see what the slopes have in common. So again, parallel lines are lines that run in the same direction. So looking at this, I'm going to highlight parallel lines. So I see that AB runs in the same direction as CD. Now, looking at that, the slope of AB is 3 over 5. The slope of CD is also 3 over 5. Okay, let's look on the other side. On the other side, I see that AD is parallel to BC. They run in the same direction. Let's look at their slopes. So the slope of AD is 5 over 3, and the slope of BC is also 5 over 3. So let's summarize our results. AB is parallel to CD, and they both have a slope of 3 over 5. I also note that AD is parallel to BC, and they have a slope of negative 5 over 3. So the slopes between each don't have to be the same, but since these two line segments are parallel, they have the same slope. Since these two line segments are parallel, they also have the same slope. So how do you tell if two line segments are parallel? They are parallel if their slopes are equal. So let's try an example. Let's say I have endpoints AB and endpoints CD. I want to find the slope of each and determine if they are in fact parallel. So let's do the slope of AB. So remember the formula for slope, y2 minus y1 over x2 minus x1. It doesn't matter which one you call x1 or y1, as long as my first point, I use x and y for both for the first, and in the second one, as long as I use x and y as 2 from the same point. So I'm going to label it like this. So I'm going to do y2 minus y1 over x2 minus x1. So the slope of AB is going to be negative 3 take away negative 6 is positive 3 over 2 plus 2 is 4. So the slope of AB is 3/4. Now let's determine the slope of CD and see what happens. So for the slope of CD, again, my formula is y2 minus y1 over x2 minus x1. So I'll call this one my first point, so that's x1, y1, and I'll call this one my second point, x2, y2. So the slope of CD is y2 minus y1 over x2 minus x1. So the slope of CD is equal to 7 take away 1 is 6 over 2 take away negative 6, 2 negatives make a positive, is 2 over 8. Now remember with fractions, we always want to put those in lowest terms. So 6 over 8 in lowest terms is 3/4. So since the slope of AB is the same as the slope of CD, I can therefore say, so 3 little dots in a triangle means therefore AB is parallel to CD. Okay, let's look at perpendicular. Now, perpendicular lines are lines that intersect, and they intersect at a 90-degree angle. So that little square means 90 degrees. We denote that by like an L shape, just showing that it's perpendicular. Sometimes you'll see this with the little box in the side as well. So that means perpendicular. So let's go back to this example here. I want to identify perpendicular line segments. So I see that AD is perpendicular, there's that little L corner shape, to CD. Let's look at the slope. So AD has a slope of negative 5 over 3. CD has a slope of 3 over 5. So they're not the same, but let's see if there's a pattern. Let's look at another one. So I'm going to go over here and I'm going to say that AB is perpendicular to BC. So looking at that, let's look at the slope. So this one's 3 over 5 and this one's negative 5 over 3. So let's summarize our results here. So we said that AB was perpendicular to BC. The slopes are not equal, but let's look at what happens. 3 over 5 and negative 5 over 3. So definitely not equal. But the 3 from the top becomes the bottom. The 5 from the bottom becomes the top there. And they're opposite signs. So it looks like they are flipped and opposite signs. Let's see if that works for the next one. So we said that AD was perpendicular to DC. So AD had a slope of negative 5 over 3. DC had a slope of 3 over 5. So again, they are flipped, yes, and opposite signs. One is negative, this one's positive. So it looks like that works. So perpendicular line segments. Line segments are perpendicular if their slopes are negative reciprocals. Now let's break that down. Negative doesn't necessarily mean the slope has to be negative, but if one is negative, the other is positive. So negative in this context really means opposite signs. Reciprocal just means to flip. That means the numerator and the denominator are interchanged. They're flipped. So it's flipped and opposite signs, negative reciprocals. The one exception to that is vertical and horizontal line segments. So if I have a vertical up and down line and I have a horizontal straight across line, those are in fact perpendicular to one another, but they are not negative reciprocals. They're just reciprocals. Okay, just to refresh your memory, a horizontal line has a slope of 0. I could really say that as 0 over 1, for example. A perpendicular, an up and down vertical line segment, if I were to flip that, 1 over 0, you can't divide by 0. That's why this has an undefined slope. So they are reciprocals of one another, just not negative reciprocals of one another. So let's try an example there. Okay, same thing. We're going to find the slope of AB. So again, that's y2 minus y1 over x2 minus x1. So I'm going to call the second point x2, y2, and the first point x1, y1. Okay, so our slope of line segment AB is 5 take away 7 over 3 take away negative 4. So my slope of AB is 5 take away 7, negative 2. Here, two negatives make a positive, and I end up with 7. So negative 2 over 7. Now, using my rule, if the slope of CD was flip it, 7 over 2, opposite sign, negative becomes positive. If that is the case, then I can say AB is perpendicular to CD. Let's check, okay? So I'm going to change colors just to check my prediction. So the slope of CD, and then x2, y2. Okay, so the slope is going to be y2 minus y1 over x2 minus x1. So the slope of CD is 3 take away negative 4 over 6 take away 4. So the slope of CD is equal to, take away a negative is a positive 7 over 6 take away 4 is 2. And it's what we wanted it to be. So since the slopes are a negative reciprocal, I can say that the line segments are perpendicular. Here's another way of stating it. If they are negative reciprocals, that would mean if I take the slope of AB and I multiply it by the slope of CD, I will get negative 1 because they are negative reciprocals, flip and opposite sign. So since that is true, therefore I can say that AB is perpendicular to CD. Okay, so negative reciprocals. Let me just show you on the side here. If I were to multiply those together, I end up with negative 14 over 14, which is negative 1. So this statement is a way of saying negative reciprocals to one another. So since that's true, I know that they are perpendicular. So that's the difference between parallel and perpendicular line segments. Parallel lines have so much in common, it's really a shame they'll never meet. So if you like this video, give it a thumbs up so I can help more mathies just like you, and I'll see you for the next one.